Hello and welcome back to the channel. My name is Eddie Jennings from EJSLLC.com. This video is going to be another in my RHCE practice session series where I am not necessarily trying to give authoritative information or do a tutorial, but rather I am doing a practice session through the objectives to see if I feel confident in the objectives and feel like I'm ready to take the exam. That being said, I do try to have the information as accurate as possible, so hopefully it'll be helpful for you with your own studies for RHCE. Perhaps you'll see a way that I handle something that might help you with your own preparations. Before I dive in, I want to thank returning subscribers for watching another video, as well as invite anyone that's watching that has not subscribed yet to click that subscribe button and ring the bell when you do. Feel free to leave comments, questions, critique, praise, whatever you would like. I will answer as I have both time and ability. If you enjoy this video, make sure you click like and feel free to share it with others if you think it would be useful for them. So this video is going to be working with the objectives under the Be Able to Perform All Tasks Expected of a Red Hat Certified System Administrator section, and it is the objective of Operate Running Systems. So as I mentioned in the last video, these first few objectives are really just a review of RHCSA stuff, because the idea behind this is to be able to do well with RHCE, then you need to have the basic competency that you would get out of RHCSA. So for these topics, I'm not going to do a real deep dive into them. I'm going to briefly discuss them and maybe do some examples of it to make sure I still feel like I'm confident with the topics. If you're wanting to see me do a practice session where I go much slower with RHCSA, which is what I did when I was actually studying for that exam, make sure you check out the RHCSA practice session playlist, which I'll link in the video description, as well as have a little pop-up up here in this video, hopefully right about this time, that you can click to check out those practice sessions as well. So if I go back to RHCSA and look at the objectives under Operate Running Systems, the first thing that we have to be able to do is boot, reboot, and shut down a system normally. So to be able to do that, if you're using the GUI, fairly simple. Go to the upper right corner. You can click what looks like the power button and click it again, and you'll have the option to restart or power off. Most likely, though, you're going to be using the command line for this. So let me go ahead and open a terminal. And the command you'll be using for this is the shutdown command. So if I were to do shutdown, there's a couple of options you can pass this. What I think you'll be using the most often, or at least what I use the most often with my lab and such, is the -H option, which is to halt or power off a system. I think -P does that as well, maybe -P, but I use -H. And you need to give it a time, such as now or sometime in the future, expressed as a 24-hour time format. And once you do that, your system is going to shut off. What I often do with my home lab server when I need to do patches and such is I'll do my patches, and let's say that there's a new kernel that was brought down, which means we need to reboot the system. But I'm in the middle of doing stuff. I want it to reboot later. So I can use shutdown -R and give it a time. Often I do it for 3 a.m. or just 3 a.m. And it tells us that a reboot has been scheduled for that time. And if you want, you can do shutdown -C, which we'll do here, to cancel that shutdown. And at this point, it is not going to reboot. Now, one thing you're not able to see in the video here, can I get it into the screen? Nah, I don't think I can. If you're using Virt Manager on a virtual machine, you can view your console of the virtual machine, and you'll have some buttons that you can click to shut down stuff from a virtual machine console. And then of course, if you're working on the command line, you have the virsh commands for starting and stopping virtual machines that would probably fall into this as well. So the next thing that's on that Operate Running Systems list is booting into different targets manually. And what this refers to is systemctl isolate. So briefly, systemctl has a variety of targets, and these targets are unit configuration files that basically say these particular things need to be running if we are going to be in this, for lack of a better phrase, like state of machine with the target. The target that you're in right now with this is the graphical.target. And so if we were to load the graphical target, then that's going to bring everything that we need to have a GUI interface. It's going to start GNOME shell and various other little things that go along with being in the GUI. Now, if you're in the multi-user target, which is usually the target you're going to be in on the server, that's your command line target, it will have, when you call the multi-user target, it's going to run everything that you need for that command line session. You'll have networking and all sorts of other stuff, but you're not going to have the GUI things that you need for GNOME shell. So the way you can tell if you can move into a target like this manually using systemctl is by looking for allow isolate. So if I were to go into, I think it's user lib systemd system, pretty sure that's the directory. We'll do ls target. Yep, there's all of our targets. So if I were to cat, actually let's look at the multi-user target. Multi-user.target. And notice it says allow isolate yes. All right, so this means that I could use this command, which we'll do sudo systemctl isolate, and then the name of the target. So I'm going to do multi-user.target. And if I press enter, feed it my password. And so feed it the correct password. And so what you can see, and this might be real tiny on your screen because I don't have the nice 1980 by 1020 or 1080, something like that. Whatever the HD resolution is. Obviously, I don't have this here, and we see that system shutdown has been canceled. Yep, that's what we want. Now I should have my little prompt. Should allow me to type. Let's see. This is odd. So let me reboot my VM real quick. We'll do a force reset. Yes, I'm sure force reset. All right, so this should boot back up. It'll take just a moment or so. That was odd. I'm surprised that it did that, shutdown was canceled. We're going to try this once again once it finishes booting up. While we're waiting on this, one thing I did ask in my introduction video for this playlist was some feedback from all of you viewers about whether or not you want to see me struggling with something. Well, this is an example of it. And if you're on the exam and something happens like this that you're not expecting, well, you have the opportunity to troubleshoot right then and there. I'll bet I need to do sudo shutdown -c for that. Well, either way, we'll try this again. We're actually going to try this without sudo. Systemctl isolate multi-user.target. I'll have to elevate anyway. If I don't fat finger the password. That's weird. I am totally expecting that to just basically take me into just having to log back in, but at the console, rather than have our graphical target. That's really kind of weird. I'm not quite sure why that's doing what it's doing. Let's try, was it Control Shift 1, 2, 3. Yeah, that should work. Maybe this is because it's a VM. That's weird though. So we'll force the reset again. And we won't mess with that anymore. But the isolate is the command to make that work. I'm just wondering why that's being screwy on my VM. Might be something I need to look at prior to taking the exam. Perhaps I'm doing something wrong. If I am, and you notice that and want to put it in the comments, by all means. And I encourage you, even though I do, these are practice sessions rather than tutorials, and I do try to make the stuff as accurate as possible. If I do make some mistakes, feel free to call it out there. Be respectful about it. Don't just go, har har, you are dumbs. Nope, actually, say, hey, you made a mistake. This is what you should do. It'll help me with my preparation, as well as anyone that's watching these that's using it as, supplement to whatever preparation they're doing. They'll get the accurate information. It's kind of curious though that that's even an objective, because everything you do configuration wise on these Red Hat exams has to survive a reboot, and obviously that's not going to survive a reboot. You see that we're back here in the graphical target, but if you were to do systemctl set default multi-user target, then that will survive a reboot. But moving on, the next thing is interrupting the boot process in order to gain access to a system. I'm going to save that for the end, because I'll stop and restart OBS to do a console session that will hopefully be a little bit easier to read on the screen, and you can see the steps for that. This is an important thing to be able to do, and not just needing to know it for RHCE, but for real life. Let's say that you are administering a Linux system and you can't get into it and no one knows the root password. This is, or specifically you're working with a Red Hat based system like CentOS or Oracle Linux or on and on and on. You need to know how to do this to be able to get access to that system. So we'll come back to it in just a few minutes. The next thing on this list is identifying CPU and memory intensive processes and to kill processes. So let's go back to our terminal here, and we're actually going to make a second terminal window. So we'll move that over there. And what I'm going to do is make a few, yeah, I'll do this. Make a couple of tabs here. And what I'm going to do is start Vim in all of these tabs. All right, so if I go back to our original tab here, and if I were to do top, you're going to see, might not show up too much because these aren't using much CPU. Should show some of our Vim stuff. Let's do this. Let's start typing with one of them. Is it going to make it show up? It should. Boo. Come on, top. Do what I want. Well, if I were to do pgrep Vim, yeah, there should be 3 processes here. So let's take note of that. One of the processes is 2893. So with top, what you can see are your current running processes, which I'm really surprised that Vim is not here. It might be part of terminal, maybe. Odd. I totally expected to see see Vim here with the processes, unless it's simply not showing them all. Anyway, so let's say that you're using top to be able to look at CPU utilization and memory utilization. You can also check out load balancing as well. This is probably the go-to program for identifying stuff that might be eating a bunch of processor time on your system. There's also a tool called Glances, and I think there's one called HTOP. Those tools I've heard people use. I haven't used them myself, but if it's available to you, I'm sure you can use those for your diagnostic stuff. But let's say that we've identified one of these processes that we need to kill. I think it was like 2813 maybe. Let's quit top real quick. pgrep vim 2893, that's it. So let's go back to top. And while you're in top, you can press the K key, and what that's going to do is send a kill signal. Now, kill signal does not necessarily mean killing a process. That simply is sending a signal to the process to do something. Now, there is a kill signal called kill-9, which is stop whatever you're doing, don't have a clean shutdown, stuff may get corrupted, oh well, stop now. But what you're most likely going to be using is sigterm 15, or the kill signal 15, which is sigterm, which is stop what you're doing, but do your normal stopping of the process. So if you wanted to do that from within top, you press the K key and then you feed it your process ID, so 2893 for what we want to kill. And then it asks you what signal you want to send it, which by default is going to send the sigterm. And if I press enter, we go back to here, we're going to see that one of our Vim sessions has been terminated because we have sent that signal. Another way to do this, and you saw me use the pgrep command. This is a common one that I'll use to try to get process IDs. and you can feed it the name of a process. And it's very similar to doing like PSAUX and then piping that to grep to be able to get your process ID. You can also use pkill, but I caution you with this because much like pgrep will give you all of the process IDs, pkill will kill all of those processes. So be careful when you use pkill. You might kill processes that you're not necessarily wanting to have slain. Otherwise, you can actually use the kill command. If I were to do man kill, you can see the format here. You'll give it the signal number. You can also do the signal word, I believe, too, like sig term, sig kill, and then the process ID for your process. Another thing you can do if you've forgotten the name of your different kill signals and their numbers, kill-L will give you a list of that. So very useful on the exam should you need to be able to do that. Now, the next thing I'm going to go ahead and tell you that I will need to refresh a bit before I take my RHCE exam, mainly because it's something that in my lab I have never had to touch, and some folks I know that work a lot as Linux administrators really don't have to touch this. Now, of course, there will be someone out there that has to do this a lot, and they're going to say, oh, this is the most important thing ever, and it probably is. It's just something that I haven't had to touch much yet, and that is working with process scheduling. This is different than using nice and renice as far as those commands to just change the priority. You know, a nice of -20 is I'm the most important thing ever. Nice of 19 is do my process, you know, whenever you get to it, to 0, which is kind of the normal thing. Process scheduling deals with the actual scheduler. And we're going to take a look at man real quick for that. And let's say that you're like me on the exam and you rarely touch process scheduling and you've forgotten everything. Man-K to the rescue. We're going to look at schedule for that. And we see we have scheduling policy, which is the thing that we're wanting to look at here. So we're going to do man sched get scheduler. And this will have, if I scroll, I think this is what I want. I'll scroll down a bit. Is that what I wanted? It talks about, yeah, here we go, the different schedules. Most stuff is going to be in schedule other, which, you know, the kernel is basically making its most educated guess as to how much process time stuff gets. There are some things that need to have be in the FIFO schedule, and these are more like mission critical kind of things that, you know, you can't necessarily trust the kernel to do the scheduling for you. You need to explicitly dictate, you know, how much time, process time. This isn't necessarily time as how a watch goes, but like processor time will go to your individual processes. I'm going to go ahead and tell you that I have just a very kind of high level understanding of this. I have not delved into it, so I'm not going to play like I know a lot about it here on the video. And also there is a command for setting this. And that command, I'll go and tell you, has escaped me right now to the point that I can't think of enough to even find a man page to be able to find that. So that'll be something that I will take time outside the video, obviously, to review before the exam. So I at least want to have enough of a clue in my head about it. One thing, though, when you're working, as far as what I remember when I dealt with this a bit more on RHCSA, preparing for that, when you are working with the process scheduler, these things don't persist to the best of my knowledge. So that's why I don't think it's likely you'd have to do this on the exam much. And of course, there's no way for me to know. And even if I did, I couldn't tell you because of NDA. But I don't think it's likely that you'll run into it just because it's not something that can persist. And all configurations you do on a Red Hat exam have to be able to survive a reboot. And so if it doesn't persist, obviously not going to survive a reboot. But this is where you can get a little bit of information about it. Moving on in the list, we have managing tuning profiles. Now, this is a nifty little thing here. So let me clear my screen here. This is going to be using the service called TuneD. So if I were to do systemctl status TuneD, we see that the system tuning daemon is running. Now, let's say that this is not installed on your system and you can't remember the name of the package that you need to grab. Nice little trick for this, DNF or yum, what provides also I think provides does it as well. And then we'll do tuned ADM, because that's the, not tune ADM. Let's try this again. Tuned ADM, because that is the command that we're going to be looking at in just a moment. Of course, it's going to complain a little bit about not being root, but we see that tuned is the name of the package that would need to be installed for that. So if I were to do tuned ADM list, what this is going to give us is a list of all of the little tuning profiles. And what these are pre-configured optimization settings for a Red Hat Enterprise Linux system. For example, let's say that you're working on a laptop and you want to squeeze as much battery as you can possibly get out of it. You would set your tuned profile to power save. So while you might lose some performance and such, hopefully you will not be using nearly as much power with that. So with these, you can do tuned active or tuned ADM active. This will tell you what the what profile is currently active. Here it's virtual guest, which makes sense because this is a VM running. You can also do, I think it's tuned ADM recommend is the command. Let's see what happens here. It tells you virtual guest. I don't know if that actually changes it to virtual guest, but rather it has an algorithm. It figures out which of these profiles that you want, and or which profile will probably be most appropriate for you, and recommend it. To change your profile, tuned ADM profile and then the name. So let's change it to that power save. And then if I were to do tuned ADM active, we see the current active profile is power save. This is a persistent setting. So if you were to change tuned profile and reboot your system, it is going to remain the profile that you changed it to. So we're just going to change it back. ADM virtual or profile virtual guest. And while we're on the subject of tuned, let me clear this here. Let's go into etc. Where would that? Yeah, there we go. Tuned and cat active profile. I think it's just going to list it. Yeah. There was, maybe it's in user lib. Let's check. User lib, tuned. That's what I want. All right, so let's go into balanced. Yeah, and let's vim tuned.conf, not conf. Okay, so this is where you can actually configure the different profiles themselves. This is something that you're probably not going to have to do on the exam. Of course, there's no way for me to know. And I imagine in real life you might not be touching these too much, just because these things are made by Red Hat to use. You may be able to make your own profiles. I can't remember off the top of my head, but if you ever wanted to see what the settings were for these profiles that come from Red Hat, the print working directory here, user lib tuned, and then whatever the name of the profile is, you can check that out. So moving on, we have a couple of objectives that deal with logs, and the first is locate and interpret system log files and journals. So to be able to do that, let's clear our screen. We're going to head into the var log directory, and we see a lot of logs here. I think we looked at some logs in the last video. I think it was the kdump log, and where we were using grep and such with, but this is where most things are going to store their logs. Now, there is a service likely running on your system called RHCSA, which tells the system where to store its log files. So if I were to vim, I think it's etc rsyslog.conf, I think is what I want. Yeah. And this, I'm not going to go into a lot of detail here, but this is where you can dictate, where logs are going to be stored. For example, this is something you can say a particular type of log, such as mail and cron, or a particular, I guess not status, severity of log, like emergency, informational, debug, warning, error. You can dictate where those logs are going to go. For example, all of these types of logs, so information logs, mail that does not have a severity to it, all of that goes to var log messages. Anything from the auth priv log goes to var log secure. This is where that is going to be configured. So let's move out of that, and we can see we have mail log and such that's in here as well. The other piece of this is using journal CTL or systemd journal D. What this does is gives you a nice kind of not a graphical interface, but an easier way to be able to see information from all of the logs that are being gathered on the system. Let me show you what I mean by that. So if I were to clear my screen here and just do journal CTL with no commands, notice it says logs begin at 21:28. That was the last time I rebooted this machine, and this is everything that has been going on since that last reboot. Now, one nice thing about this, and this is something that I've used fairly often with my own systems trying to troubleshoot something, is the since parameter. So it's currently 21:46. So let's clear the screen here, journal CTL since 21:44. So in the last 2 minutes, this is all the stuff that has happened within our last 2 minutes. We have a bunch of warnings from GNOME shell. Now, I think there are some other things that you can plug into since. You might be able to use do a subshell with date command to be able to get a bit more stuff about it. You can also, and I can't remember the command off the top of my head, I would have to refer to the man pages if I needed to do this in the exam. You can also tell it a particular systemd unit, such as if you're wanting just things that were logged by httpd.service, there should be an option for journal CTL to be able to see just httpd.service logs and such. There's another option, I think it's XE, might just be X, but what that will do is give you a little bit of additional information about the logs. If you have a service that fails to start, it'll often tell you to use journal CTL-XE, and that can give you some information that might be helpful with troubleshooting. So moving on, preserve system journals is that next objective, and there's a couple ways of doing this. The easy way is by making a directory within var log called journal. By default, persistence is set, or I think it's storage actually, is set to auto for systemd journal D, and being auto, it basically means that if the folder journal exists in the var log directory, then journal D is going to, the information in journal D is going to persist. And I'm pretty sure you just restart the service and that'll start persisting for you. The other way to do it is we can go into vim etc, I think it's journal D, no, systemd, then journald.conf, and we would uncomment the storage item and change that to, I think it's persistent. You can also change it to volatile, which says that it will only be stored in memory, and I think that is going to be under run log is where that would be stored if it's just in memory. But again, if it's just in memory, it's not going to survive reboots. So I would say if you're on the exam and you have to make this persist, just simply make the directory within var log, the journal, not journal D, but journal directory. So next we have to work with start, stop, and check the status of network services. So there are a variety of services that we can use for this, but let's SSH into one of our lab servers. SVR01, feed it the password. So now we're in SVR01. Let's use good old Apache. So sudo dnf install httpd-y. Is this 2 in a row? Yes, 2 in a row of doing the correct password means that we're going to have a good finish to the video, right? So this shouldn't take too long to install. And if we wanted to check the status of Apache now that it has installed, we can do systemctl status httpd, technically we do httpd.service, but what this is going to tell us is that the service is disabled and it is inactive. It is dead. There is nothing going on with httpd. If we wanted to start the service, I'll probably have to use sudo for this, but systemctl start httpd. Go back up and do the status. Now we see that it is running. It is still disabled, but it is running. And if we wanted to stop the service, systemctl stop httpd. And if we check the status, we see that we're back to the fact that the service is dead. Now remember, with Red Hat exams, now you've probably heard me say it a few times in this video already, but you can't forget this. Any configuration you do has to survive a reboot. So therefore, if you have something that requires you to do Apache, you're going to need to enable it. And to do that, we will do sudo systemctl enable and the service name. Now, if you don't want to do a separate command for both enabling the service and starting the service, you can do --now with systemctl enable. And what that's going to do is enable the service as well as start it at the same time. You can see enabling a service, really what that's doing is making a symlink for the multi-user target once, which that's the target that I'm in, and basically says if we're in the multi-user target, we want the httpd.service unit configuration file to be loaded. So let's clear the screen and systemctl status httpd, and we see it is both running and it is showing as enabled. So we will definitely have to do that if we were working with Apache on the exam. So next to last, actually, we have securely transfer files between systems. Now, a couple of tools you'll use for it. I use SCP more often than not. That's secure copy, basically copying stuff over SSH. There's also SFTP, which is FTP over SSH. That I'm not going to demonstrate this in the video. It's fairly easy to do SFTP user at hostname, and you can do FTP commands for that. But I am going to demonstrate SCP for you. Either will likely be available. I know SCP is going to be because you're going to have SSH most likely. SFTP I'm like 90% sure would be available without needing to install something. And probably if you're a master of SSH out there, you're going, of course it's going to be available if you have SSH. But anyway. So using SCP, let us, I still have a file here. Let's cat foo.txt. All right, so it's test file. So we have our foo.txt test file. If I wanted to send that to one of my other lab servers securely, and I want to use SSH for that, I can simply do SCP, the file name, the user at the server, 02, then colon, and then you need to give it a file path where you want it to go. So we're just going to dump this in the temp directory. Now, notice I wasn't prompted for a password. In a previous video, I think we set up key-based authentication between these two servers, so I wasn't prompted for a password. Otherwise, you would. So if we were to cat, we can do this actually, run the command remotely over SSH. So Eddie admin at my server, and just cat temp.foo.txt, we should get the text that we expect because we copied that there. You can also copy in the opposite direction as well. So let me remove foo.txt from SVR01. We can do SCP user at host colon the file that we want, and then where we want to send that file to. I just want to drop it into the current directory that I'm in, so I'm just going to do a dot for that. And ls, and there's our file. We'll cat it, and test file is back. So that's us going through our securely transferring files between systems. So that is all but one of the objectives within the old RHCSA operate running systems, which you would need to be familiar with for RHCE. I'm going to pause the video for just a moment and reset OBS to be able to have a little bit better view of a terminal window, and we're going to go back to the objective of being able to interrupt the boot process to gain access to a system. So we'll be right back. All right, and we're back. This hopefully is not going to be too difficult to see, but it's just the way it is when you are on the actual console and you don't have your nice resolutions and such. So let's say that, I have a system here and I have no way of accessing it. No one's given me a username or password. No one knows the root password. What do I do? So what we're going to have to do is interrupt the boot process. So let me force a reset on this server here. And the first thing I'm going to do, once I get to the grub screen, I am going to press really any arrow key to stop the countdown. And what we are going to be doing is editing one of these boot entries. So I'm just going to do the top one here. We're going to press E to edit. And what we're going to do is find the Linux line. And even though this looks like several lines, it's actually not several lines. It is really just, I think, 4 maybe. So I'm going to go all the way down. We're going to go backwards. We have the initd. All right. And what we're going to do after quiet here, we're going to add rd.break. What this is going to do is interrupt, or where we've already interrupted the boot process, but we're going to stop the, I'm trying to remember what RD stands for. I used to know that, but it has since escaped me. But we're basically going to stop this process long enough to be able to set a password for root or for any other user that you would want for that. So we'll do Control X, and that, after just a moment or so, hopefully this will be readable for you, is we're now going to be in emergency mode. And this is, if you remember some of the targets for systemd, this is one of those targets, like a low level, please get my system functioning again. Now let's see, it's actually been a little while since I've done this, so let's see if I can remember the steps for this. So first of all, what we have to do is, if I were to do mount, we see our current mounts and such. What we're going to need to do is remount one of these, and I believe it is sysroot. It's either sysroot or sys. Let's see if this will give me what I want. All right. My gut tells me sysroot. So let's try that first. So we're going to remount, mount-o, remount, read write, comma read write. Because basically we need to be able to actually write to what's going on here. I'm pretty sure it is sysroot. Well, we'll find out soon. All right. So once we do that, we need to change root into sysroot, because if we were to just do passwd root here, it's not going to find that. And mainly, like when I did that ls, it looks like we're missing some stuff. So I'm going to change root into sysroot. All right. And if I were to do ls now, we have what looks much more like a root directory. Now we will have access to passwd. I think I can clear my screen too. Yep. Passwd root. And we're going to give it a password, monkey123, and it's going to complain, but I'm still going to use it anyway. And all passwords have been successfully done. We're not done yet. We need to touch a particular file. And the file that we're going to touch, and we're doing this in the actual root directory, is going to be a hidden file called auto relabel. And what this is going to do is tell SE Linux to rewrite file context, because otherwise the change that we basically have made to the etc shadow file for root is not going to persist because of SE Linux. Now you can turn off SE Linux, I think, at the boot command as well, but the touch.auto relabel is kind of how I was taught to do it, and that's what I tend to stick with. So we'll exit our change root. We will exit, let's see, exit here, log out. Is that what I want? Yep. And it's going to warn that we're going to relabel the file system, and this is going to take a little bit of time. But once we reboot, we should be able to get in with root with that password. So I'm going to pause for just a moment. I'm not quite sure how long this is going to take, But if it's not too long, we'll just keep going with it. Otherwise, I'll pick back up the video after a couple of minutes. All right, so we had a successful boot. Let's see what happens. Root, monkey, monkey 1, 2, 3, and I'm now in my system as root. So I guessed correctly about sysroot for the volume. Now, if I got lucky and sysroot just happened to work and I'm wrong about that, as I mentioned earlier in the video, feel free to leave a comment correcting me. I'm trying to be as accurate as I can, but I cannot guarantee perfection. So I want to thank again returning subscribers for watching another video, as well as thank all of you for taking the time to watch. If you enjoyed the video, don't forget to click like. Feel free to share with others as well. If you haven't subscribed, subscribe or click the subscribe button and ring the bell when you do. And I will see you the next time.